So in this video, we are going to solve Leetcode question number 230, kth smallest element in a binary search tree. The main motive behind this video is to tell you how to express yourself and how to express your thought process for solving a question in front of interviewer. Because the main thing in the one-on-one technical interview is the communication and telling what approach you are thinking. That's the main thing which they are looking for. Then they look for the solution, whether you are able to go for the right path of the solution or not. And then they will look for the whether you are really able to produce output or not. But the main two things they do first, and that's what our main focus in this video by solving this question. If you guys would have been aware about in order traversal, or maybe you saw my previous video, you know this question is very easy. Then it is not a medium level question for you. You just have to put little bit thinking now. So let's read the question. Given the root of a binary search tree and an integer k, return the kth smallest value, one indexed in the sense this is 1, this is 2, not this is 0, this is 1. Okay, that's what one index means. Of all the values of the nodes in the tree. Most probably you got confused by the question, but the question saying is, so see, you have this 3142. Okay, this is a BST. Okay, and you got index 1. So it's saying one index. So if you create a ascending order array of this BST using in order traversal, I told in previous video also. If you do that on the first index, what will be the element? Obviously, it will be the 1 because it is a one indexed array. That's what the question is asking from you. Similarly here, if your index is 3, then what will be the answer? 1, 2, 3. 3 will be the answer. See, same thing. So let's see how we can solve this. It is pretty simple. I think so most of you will be able to judge the answer by now, but still. So yeah, we will first create a private void helper function. Okay, helper function. Let's just name it in order, also in order helper, and we will pass our tree node root, but with the name this, and we have to also pass int k so that we can match. So yeah, so why we created this is, we created this because we don't want to return something from this function. Okay, so we are not returning, we will be manipulating. How we will be manipulating is, we will create we can say we will create a counter first. So k is the index, so we need a counter for it. So this is a counter we will create. So for iteration like first, two, second, third, this iteration we need the counter to count it, and we will create a result also. And yeah, the point is, if the node is null, if there is nothing in the tree, then what you have to return? You have to ask your interviewer. These things you have to ask. Here, if there is nothing, most probably we have to return -1. We will see, no issue. And they have given us some constraints. Okay, we are lying inside constraints by default itself. Okay, this is the basic thing. So this is the answer, and this is my index counter. So by this I will count the index. Okay, and what I will do is, I will just call in order helper here with root and k, that's all. And if you, in any case, I will just return result. Okay, now first thing, we have to handle the base null case. So if node is equals to null, just return null, not return anything, just let it be. Just go back to the kth smallest and it will return -1. Otherwise, we have to do in order traversal in in left direction. Why in left direction? Because we need to do we need to do in order traversal to get the ascending order. By getting the ascending order, we can have the one indexed element. Okay, like the not one index, sorry, the given index element. Okay, so for that we are doing first in order traversal in the left direction. For that again we will call in order helper, and we will just write node k. That's all. But here you have to write node dot left and k. Yeah. Similarly, but now in order step only, we will have middle part. In this middle part, our main logic comes. So in this middle part, what we have to check first, if we are reaching, okay, first if we are reaching, suppose here we are from, we went to 2 and we came back to 1. This is the middle part now. If we are reaching here, we have to increase the counter because we got one index, first index, so we will increase the counter. So here counter is increased. Then we will check if current index means node dot value is equals to the k. If it is equals to the k, then we got our answer. Then we will just do I just let me check here. Result, result is equals to node dot val, obviously, and return. That's all. Otherwise we have to do nothing. We will do just in order traversal, sorry, right direction. Okay, we will do in order traversal in right direction. In order in order helper in node dot right and with the k. Yeah, that's all. So I think so. Let's do a dry run quickly. Suppose we are on the 3, so we did in order with 3 and the value 1. We came in the node null part, it went here, it gave node null in the left side. Then it will go back and up, it will go back up. Once it went back, the node is not null, so it increased the counter. So now our in counter act as an index, so our counter is index. So now we have index 1, and we checked if node dot val is equals to k. Okay, k is our index. Sorry, we don't have to check node dot val is equals to k. We have to check counter is equals to k. Then we will make result is equals to node dot val and just return it. Otherwise, if not, then this is the in order traversal right side. Okay, so yeah, this is the main logic which we did. So here, if counter is equals to given given index, then we will have the answer. That's all. I think so. This should run. Let's do a submit. I should have done run first. Okay, no issue. Some issues, maybe compile error it is saying. Oh, yeah, it worked. Great. So yeah, we got a 0 ms. It means it's quite fast. And wait, let me just go quickly to the, yeah, it's good. So now let's wrap it quickly. So why we did in order traversal? Again, that's the question. Maybe interviewer you will ask you why in order, why can't any other? The point is, whenever we do in order traversal, so whenever you do in order traversal in binary search tree, you get a ascending order value. Because you get the ascending order value, because of that you can get the kth index in this question. So smallest value of the first index, you can get the kth index. Basically, by in order you are starting from the smallest value of the tree. That's why you are doing the in order. So basically we are starting from the smallest value of the tree, and hence in order is usable. Okay, and another thing is, he can ask you recursion stack. This is a homework again, because it's simple, it's not quite hard. You should know recursion to solve tree question. So you should do recursion stack as the homework. Let's see the time complexity quickly. So in the worst case, obviously we are gonna have O of n. It means we will traverse all the node. But in good cases, we will not have O of n, because as soon as we will find our index, we will stop there itself. So O of k you can say, okay, or maybe something else like, but not O of n at that time. And space complexity, we are having a counter, and we are having a result. So we have two things. So based on this, our space complexity is also, in worst case it will be O of h. So O of h times we will change. H means height of the tree. We will change it. Otherwise it will be normal only. Log n or log h. Okay. Let's see. I have made. I think so. Maybe for this also notes. Yeah, here. So we have, as I told, we are doing in order traversal. So worst case we will go every node, so O of n, and best case it will be log n, as normally we have. So we have O of n, and space complexity, in the worst case we will go all the nodes. So basically O of h, height of the tree, but in the good case it will be the log n, so O of h. So we have our space is complexity is O of n, and time complexity is also O of n. And I hope so you understood the video, and this is how you should explain in your interviews also. Thank you, and keep learning.